Hello students, welcome to Real Academy. My name is Rajendra Chaudhary and I am a maths faculty here. Today we will be discussing the topic Heron's formula. Okay, as you can see, the person who derived this formula is Heron of Alexandria. Basically, he is a Greco-Egyptian mathematician who is often credited with other scientific inventions as well. For example, the windmill that we know today, he is often credited with the original design for that windmill. So apart from being a mathematician, he was also an engineer and inventor. So he was a great personality. Today we will be discussing one of his formulas, which is a very famous formula known as Heron's formula. Let us see why this formula is used for. Let us go to the next page. As you can see on the screen, I have drawn two triangles here. The first triangle is triangle ABC. And for this triangle, you can see that the base of the triangle is 10 centimeter. It is known to us. Also, the height of the triangle is known to us. Okay, it is 12 centimeter. We all know how to calculate area of a triangle, correct? We know it from our previous standards that area of a triangle can be calculated as half multiplied by base multiplied by height. Okay, when we know the base and height of the triangle, this is how we can calculate the area of the triangle. It's very simple, correct? Substitute the values half. The base of this triangle is BC, that is 10. Height is 12, correct? You can cancel this out. 12 into 5, the answer is 60 centimeter square. Okay, the area of this triangle is 60 centimeter square. Now coming to the Heron's formula. Why is this formula used? By now you must have guessed that it has something to do with area of triangle. Okay, when we know the base and height of the triangle, this is the formula how to calculate the area. But when we don't know the height of the triangle, but we know the sides of the triangle, that is when Heron's formula is used. Okay, here height is given, base is given, it is easy to calculate the area. But when the height of the triangle is not known to us, but the three sides are known, the lengths of three sides are known to us, correct? At that time, Heron's formula is used. As you can see, this is another triangle ABC. Okay, in this triangle, the three sides AB, BC and AC, their lengths are known to us. Let us consider this as A, this as B and this as C. Okay, length of all three sides are known to us, correct? Now, what is Heron's formula? Let us discuss it. First step towards the formula is to find out something called as semi-perimeter. To use Heron's formula, you must first find out semi-perimeter. Okay, semi-perimeter is also denoted by S, and the formula to calculate the semi-perimeter is very similar to the perimeter, correct? Perimeter क्या होता है किसी भी diagram का? The addition of all three lengths of the sides of the triangle, correct? If I add 15 plus 14 plus 13, that is the perimeter of this triangle. The boundary of any figure is known as the perimeter of that figure, correct? So here, semi-perimeter is A plus B plus C, perimeter and uska half. Okay, so semi-perimeter of a triangle is the sum of lengths of sides divided by 2 for the triangle. Okay, so what is the semi-perimeter here? 13 plus 14 plus 15 divided by 2, which will be equal to 42 divided by 2, that is 21 centimeter. Okay, semi-perimeter is the first step if we want to find the area of this triangle. By Heron's formula, the first step is to calculate semi-perimeter. We got it as 21 centimeter. Now to the actual formula. So the Heron's formula is this. Area of a triangle will be equal to square root of S multiplied by S minus A multiplied by S minus B multiplied by S minus C. Okay, what are the values of S, A, B and C? So S is the semi-perimeter, A is one of the sides and B and C are the other two sides of the triangle. Let's substitute the values here. This will be equal to square root of S is 21 here multiplied by S minus A. So 21 minus 15 multiplied by S minus B, 21 minus 14, multiplied by S minus C, so 21 minus 13. If you calculate this, it will be equal to square root of, this is 21 as it is, multiplied by 21 minus 15 is 6, 21 minus 14 is 7, and 21 minus 13 is 8. Correct? We just need to find the square root of 21 multiplied by 6 multiplied by 7 multiplied by 8. Now, if you know 8 can be written as 4 into 2. Correct? 8 is nothing but 4 multiplied by 2. तो उसमें से जो 2 है वो हम लोग 21 को मल्टीप्लाई कर देंगे. It will become square root of 21 into 2 becomes 42 और ये 8 का 4 अभी बचा है सिर्फ क्योंकि 2 हम लोगों ने 21 को मल्टीप्लाई कर दिया. It became 42 and 6 into 7 is again 42 multiplied by 4. Okay, तो इसका वैल्यू अब ये हो गया square root of 42 into 42 into 4. Why I have written it like this? Because you know how to find the square root. If there are pairs under the square root, we can take outside one number. Correct? तो root of 42 into 42 बाहर आ जाएगा only 142. That is 42 multiplied by square root of 4. We all know square root of 4 is 2. So the answer is 42 into 2. That is 84 centimeter square. Okay. This is how you calculate the area of a triangle using Heron's formula. So when you know the base and height of the triangle, we use the normal formula, which is half into base into height. When you don't know the height of the triangle, but you know the three sides of the triangle, lengths of three sides of the triangle, at that time we use Heron's formula, where first you have to calculate the semi-perimeter given by a plus b plus c by 2, and then use the Heron's formula, which is s minus a, s minus b, s minus c, the whole root. Correct? So this is what the area of triangle is using Heron's formula. Now let us solve some more questions using Heron's formula. These types of questions are there in your textbook. We'll see them. Okay. Going to the next page, you can see there is a diagram given to here. We have to find the area of quadrilateral ABCD. You can see it is a quadrilateral ABCD. We have to calculate its total area. Now this is not any regular known quadrilateral, right? It is not a square, it is not a trapezium, rhombus or a rectangle. So uska koi formula nahi hai hamare paas. But if we divide the quadrilateral in two parts, where this is one part, triangle ABC, okay, and the other part is triangle ADC, and we separately find out the areas of these two triangles and add them, we will get the area of the entire quadrilateral. First, let us find the area of triangle ABC. As you can see, ABC, this angle is 90 degree. So area of triangle ABC. Here we don't need to use Heron's formula. Why? Because the height of the triangle is 3 and the base is 4. Both are known to us. We don't need to use the Heron's formula. Correct? Let us directly write the formula. Half into base into height. Let us also mention what are the base and height here. Half multiplied by the base of this triangle is BC, side BC, multiplied by the height of this triangle is side AB. Okay, so all you have to do is substitute the values of their lengths here. BC is 4, AB is 3. So the answer is 6 centimeter square. Okay, we got the areas of one of the triangles, 6 centimeter square. Now coming to the second triangle. Okay, here we don't know the height of this triangle, but we know two sides of the triangle, only two sides. How do we find out the third side? If you look carefully at this diagram, okay, the hypotenuse of the first triangle, this triangle, is the side of the second triangle. So iska hypotenuse hum logo ko calculate karna hai by using the other two sides. How do you do it? Simply use the Pythagoras theorem. Correct? So in triangle ABC, again if I use Pythagoras theorem, in triangle ABC, by Pythagoras theorem, we can say that, okay, AC square will be equal to AB square plus BC square. Substitute the values. AB square will be 3 square, BC square will be 4 square, 9 plus 16, 25. Okay, this is the value of AC square, but we need the value of AC. So we will take square root on both sides. AC will be equal to square root of 25, that is 5 centimeter. Okay, so we got the third side of this triangle, that is 5 centimeter. Now we have all the three sides of this triangle. We just need to find the area using Heron's formula. Why? Because we don't know the height, but we know the three sides. Correct? So in triangle ADC, the second triangle ADC, in triangle ADC, what is the first thing we do to find the area by Heron's formula? Calculate the semi-perimeter. Correct? Semi-perimeter will be equal to sum of the three sides, sum of lengths of three sides divided by 2. Correct? The three sides are 5, 13 and 12. So 5 plus 13 plus 12 divided by 2. Okay, that means 30 divided by 2. The answer is 15 centimeter. This is the semi-perimeter of this triangle. Now we will use this to calculate the area of this triangle. So now the area of this triangle, area of triangle ADC will be equal to, use the Heron's formula, that is S minus A, S minus B multiplied by S minus C. Substitute the values here. Square root of S is 15 multiplied by 15 minus A, 15 minus 5. First side हम लोगों ने 5 ले लिया. Second side is 13. So 15 minus 13. Third side is 12. So 15 minus 12. Okay. Value of this will be square root of 15 multiplied by, this is 10, this is 2 and this is 3. Okay. Now if we factorize everything under the square root, we will find out that this is equal to square root of 15 can be written as 3 into 5, 10 can be written as 2 into 5 and 2 into 3 in the end stays as it is. Why we have done this? You can see here that 3 is making a pair, 5 is making a pair and 2 is also making a pair. So we can bring them outside the square root. 3 into 5 into 2. The answer is 30 centimeter square. Okay. The area of the first triangle is 6 centimeter square. Area of the second triangle is 30 centimeter square. But the main question is to find the area of the quadrilateral ABCD. What is the area then? Just add the areas of these two triangles. Correct? So therefore, area of quadrilateral ABCD will be equal to 6 plus 30, that is 36 centimeter square. Okay. So this is one of the problems that we solved using Heron's formula. There will be a quadrilateral given to you. You can bifurcate into different triangles and solve the areas of those two triangles and then add them to find the total area of the quadrilateral. Now let's go to the next example. As you can see, the next question is written over here. We will be solving this. Now the question here is to find the area of quadrilateral LMNO. Again, you can see that there is a quadrilateral given to you, LMNO. Okay. In this example as well, I have divided into two equal parts. Okay. For first triangle, you know the height of the triangle, that is 70 meters. Okay. But in the second triangle, which is on this side, you don't know the height of the triangle. We only know the three sides, 60, 60 and 96. Okay. So for this triangle, triangle LMN, we will calculate the area using Heron's formula. And for the second triangle, we just need to use half into base into height, the area of triangle formula. Correct? So first, let us solve this triangle LNO. In triangle LNO, area of triangle is equal to half into base into height. Okay, half into base is 96 and height is 70. Okay, so the value of this will be equal to 2 ones are 2, this is 2 4s are 8 and 2 8s are 16, 48 into 70. So the answer will be 7 8s are 56, 5 carry, 7 4s are 28, 3360 meter square. Okay, the units here are in meters, so meter square. Now let us go to the second triangle. In triangle LMN, okay, in the second triangle, once again we know the three sides, but this time we won't be using the simpler formula because we don't know the height. We will be using Heron's formula. The very first step while using Heron's formula, semi-perimeter. This is the first thing we need to find. Semi-perimeter is sum of the three sides divided by 2. Okay, three sides here are 60, 60 and 96. So 60 plus 60 plus 96 divided by 2. This is equal to 60 plus 60 is 120. 120 plus 96 is 216 divided by 2. So the result here is 108 meters. The semi-perimeter here is 108 meters. Now let us use the Heron's formula. Therefore, area of triangle LMN, area of triangle LMN equals to, the formula is S minus A, S minus B, S minus C. Okay, we just need to substitute the value. So this is equal to square root of, this is 108 multiplied by 108 minus, the first side is 60, which is the same as the second side, again 60, and the third side is 96. So third bracket will be 108 minus 96. Okay, if you solve this, the value is square root of 108 multiplied by, this will be equal to 48, again this will be equal to 48 multiplied by 108 minus 96 is 12. Okay, now we will factorize this in such a way that we will find pairs of numbers. Okay, 108 can be written as 12 multiplied by 9, right? 108 is 12 multiplied by 9. So I can write it as 12 multiplied by 9, again can be written as 3 into 3. Okay, 12 multiplied by 3 into 3, ye ho gaya 108. Now this is already a pair, 48 into 48, so I'll leave it as it is. And again we have 12 here, which I'll leave as it is because 12 is now forming a pair with this 12. Okay, so we have three pairs of numbers. One is for 12, second is for 3, third is for 48. So what will come outside the square root here? The answer will be 12 multiplied by 3 multiplied by 48. Okay, let us solve this. We will get 36 multiplied by 48 upon multiplying 8 6s are 48, 4 carry, 8 3s are 24, 28, 0, 4 6s are 24, 2 carry, 4 3s are 12, 1 4. The answer is 1728 meter square. Okay, so the area of the second triangle is 1728 meter square. But still, main question is to find the area of quadrilateral LMNO. Therefore, area of quadrilateral LMNO will be the addition of these two areas. Okay, area of this triangle 3360 plus 1728. Okay, if you add these two, you will get 8 here, again 8 here, 7 plus 3 is 10, 1 carry, 4 plus 1 is 5. 5088 meters square is the area of this quadrilateral. Okay, so this is another question that we solved. It is an application of Heron's formula. Okay, now let us solve one more problem. Okay, I have a word problem with me. Let us go to that question. As you can see, it is written on the board. A triangle and a parallelogram have the same base and the same area. Okay, so there is a triangle and then there is a parallelogram as well. Both of them, they have the same base and the same area. Okay, the sides of the triangle are 26 centimeter, 28 centimeter and 30 centimeters. So if this is your triangle, okay, this is your triangle, let us assume. So triangle ABC, here one side is 26 centimeter, one side is 28 centimeter, okay, and one side is 30 centimeter. And then the parallelogram stands on the base 28 centimeter. In the first line itself, they've told us that the parallelogram and the triangle, they have the same base. So the parallelogram stands on the 28 centimeter side. You can see here we have a 28 centimeter side. So the parallelogram will be like this. Using this as the base, I have drawn the parallelogram. Let this be D and E. Okay, so we have a triangle ABC and we have a parallelogram EDCB, which is on the base 28 centimeter. The question is to find the height of the parallelogram. What is given apart from the base being the same? It is given that the areas of these two figures is also same. So if we calculate the area of this triangle, we will also know the area of this parallelogram because they are same, correct? And finally, we have to calculate the height of the parallelogram. Okay, the height of the parallelogram. How do we do that? Okay, so it is not necessary that each and every time you will only be using Heron's formula or the area of triangle formula. You must also remember other formulas, correct? What is area of a parallelogram? The value of area of parallelogram formula is base into height. Okay, so we know the base of this parallelogram, we have to calculate the height, but we will also know the area of this parallelogram when we calculate the area of this triangle. So let us calculate for triangle ABC. First, we are using Heron's formula. Okay, since we are using Heron's formula, we will calculate the semi-perimeter. Why are we using Heron's formula? Because for this triangle, we don't know the height. Okay, so semi-perimeter will be A plus B plus C divided by 2. Okay, A is 26, B is 28, C is 30. Let's add them. 58 plus 26. It will be equal to 84 divided by 2. Okay, 58 plus 26 is 84 divided by 2. We are getting 42 centimeter as the semi-perimeter. Now let us calculate the area of this triangle using Heron's formula. I'll write it here. Area of triangle ABC. By Heron's formula, it will be square root of S minus A, S minus B, S minus C. Substitute the values. Square root of S is 42 multiplied by 42 minus 28, 42 minus 26, 42 minus 30. Okay, upon solving further, this is square root of 42 as it is, 42 minus 28, which is 14. Okay, 42 minus 26, which is 16, and 42 minus 30 is 12. Okay, now let us factorize it in such a way that we have pairs of numbers. 42, we all know it is 2 multiplied by 21, correct? 42 is 2 multiplied by 21. So I'll write this 42 as 2 multiplied by 21, which can again be factorized as 3 into 7. So 2 into 3 into 7, this first 42 I have factorized. Then we have 14. 14 को भी factorize कर देंगे. 2 into 7. Okay. Then we have 16. We will leave 16 as it is, or you can write it as 4 into 4 because it is already a perfect square. इसको और factorize करने की जरूरत नहीं है. Last में we have 12, which can be factorized as 2 into 2 into 3. Correct? 12 can be written as 2 into 2 into 3. Okay. After doing all of this, you will find out that there are many pairs forming here. For 2, this is 1, this is 1. So 1 pair of 2. Again, 1 more pair of 2. So there are 2 pairs of 2's. When we find out the square root, there will be 2 into 2. Again, with this, we will have 1 pair of 3's here. So 1 3 will also come outside. Okay. Then we have 1 pair of 7 and 1 pair of 4. So 1 7 and 1 4 is also coming out of the square root. Okay. This will be equal to 2 2's are 4. 4 3s are 12, 12 7s are 84, 84 into 4 is 336 centimeter square. Now this is the area of the triangle ABC, 336 centimeter square. But this is also the area of the parallelogram. The question itself says it, correct? So therefore, area of parallelogram is also area of parallelogram, which is the parallelogram BEDC, is also equal to 336 because it is given in the question. But I told you earlier that the formula for area of parallelogram is base into height. So here base into height is equal to 336. But we know again from the question that the base of this parallelogram is 28 centimeter. Correct? So therefore 28 into h is 336. What will be the height of the parallelogram? It will be 336 divided by 28. If you don't immediately find out what is 336, which multiple is 336 of 28, we can cancel it by 7. 7 4s are, again 7 4s are 28, 56 is 7 8s are 56. Then 4 1s are 4 12s are. Therefore, the height of the parallelogram is 12 centimeter. Okay, the height of this parallelogram is 12 centimeter. So this was another question where we can use Heron's formula. Again, an application of it. So I hope you understood today's session. We will stop here. Okay. If you learned something new in today's video, please do like, share and subscribe to the channel. We will be again coming up with more content like this for you people. Thank you everyone. Bye.